Visualize a specific kind of panic, pure, distilled terror. It is February in St. Petersburg. The year is 1869. Outside, the Neva River is frozen solid. The wind howls down the avenues. The sun barely rises before it plunges back into darkness. It is the deep, dark Russian winter. Inside a cluttered apartment at the university, a man is vibrating with stress. He has a wild beard. He is disheveled. He is staring at a deadline that is about to crush him. This is not academic pressure. This is not a homework assignment. This is financial ruin staring him in the face. Dmitry Mendeleev has taken a cash advance from a publisher to write a textbook called The Principles of Chemistry. He has already spent the money. He has written Volume 1, but he has absolutely no idea how to write Volume 2. Volume 1 was easy. It covered the well-behaved elements like hydrogen, oxygen, nitrogen, and carbon, the ones that make sense. But now he is staring at the rest of the chemical universe. 63 known elements in total. They are a complete mess, a jumble. There is no system, no order. It is just a pile of disparate facts. Imagine a library where every single book has been thrown onto the floor in one giant heap. If he does not organize them, he cannot finish the book. If he cannot finish the book, the publisher wants the advance back. And Mendeleev does not have the money. The invention of the periodic table, that icon hanging in every science classroom on Earth, does not start with a grand desire for glory. It starts as a desperate, frantic attempt to organize a table of contents for a textbook so a man can pay his bills. Or we tend to picture scientific titans operating on a higher plane of existence. We imagine them sipping tea in quiet studies, pondering the mysteries of the cosmos. But Mendeleev was just a guy trying to make rent. He was playing a high-stakes game of solitaire. Literally. He was writing element names on the back of old invitation cards, shuffling them around, trying to force the universe to make sense before the calendar turned. Welcome to History Titans. Before we follow Mendeleev into the frozen wasteland, take a moment to subscribe and share this story. Help us keep history alive. Now, let us go back. To understand why Mendeleev was the one to solve this puzzle, we must look at where he came from. This was not a man born into the soft intellectual salons of Paris or London. If you want to understand the periodic table, you have to understand Siberia. We need to nail down the location. Tobolsk, 1834, Western Siberia. To put this in perspective, Tobolsk was the administrative capital for exiles. It was the frontier, the end of the world. It was thousands of kilometers away from the scientific centers of Europe, a place of hard labor and bitter, relentless cold. Dmitry was born there, as the youngest of a massive family. The exact number is a matter of historical dispute. Some records say 11 children, some say 14. There are sources that claim he was the 17th child. Imagine the noise in that house, the chaos. But that chaos got worse, quickly. In 1834, the very year Dmitry is born, his father, Ivan Pavlovich, goes blind. He develops cataracts. Ivan was the director of the local gymnasium, the high school principal. But in 19th century Russia, there is no disability insurance. There is no safety net. If you cannot see, you cannot work. If you cannot work, you lose your pension. It is gone. A newborn baby, a house full of teenagers, a blind father, zero income. It is an absolute catastrophe. The family is plunged into poverty overnight. This is where the narrative shifts to the true hero of Dmitry's early life, not his father. His mother, Maria Dmitrievna Kornileva. She was a force of nature. She did not sit down in despair. She had no time for it. She came from a merchant family that owned an abandoned glass factory in a nearby village called Aremzianka. It had been shuttered for years, but with a blind husband and hungry children, she made a choice. She said, "I am going to reopen it." She packs up the family, moves them to the factory. She takes over management herself. Pause and appreciate that. A woman in Siberia in the 1830s, running a heavy industrial operation. It was unheard of. She managed workers. She sourced materials. She handled finances. This is crucial for Dmitry. Think about him as a little boy. His playground was not a manicured garden in St. Petersburg. It was a glass factory. He watched sand and ash being thrown into massive furnaces. He saw the fire, the melting, the incredible transformation of raw, gritty material into clear, beautiful glass. It was the original STEM education. He saw chemistry not as a theory in a book, but as a powerful, physical reality. You apply heat, matter changes. He soaked it all in, but the stability did not last. Tragedy in this story comes in waves. In 1847, Dmitry's father dies. Less than a year later, the glass factory burns to the ground, gone, everything. Now they truly have nothing. The father is dead. The business is ash. Dmitry is about 14 years old. The older siblings have mostly moved away. It is just Maria and her two youngest, Dmitry and his sister Elizabeth. Maria stands in the ashes of her livelihood. She looks at her youngest son. She sees something in him, a spark, a hunger for knowledge. She decides right then and there, she's going to get this boy an education, even if it kills her. That phrase is not figurative, it is literal. This decision kicks off what historians call the Great Trek. In 1849, Maria sells everything she has left, every possession saved from the fire. She scrapes together every last ruble. She packs Dmitry and Elizabeth into a vehicle, not a comfortable carriage, an open sleigh or a bouncing cart. They head west. Calling this a road trip is an insult. This is 1849. The Trans-Siberian Railway is decades away. There are no smooth highways. Maria is looking at a distance of roughly 2,500 kilometers just to get to Moscow. That is like walking from New York City to Dallas, Texas, through a Russian winter. And Maria is not young. She is already sick. She has tuberculosis. She is coughing up blood. She knows. She absolutely knows that every mile of this trek is draining the last of her life force. But she is determined. Imagine the conversations in that sleigh. Weeks and weeks of endless white snow bumping over rutted roads, staying in dirty, freezing roadside post houses. The pressure on the boy is immense. Knowing your mother is literally dying just to get you into a classroom. It is a debt that you can never, ever repay. And then comes the ultimate heartbreak. After months of this grueling travel, they finally reach Moscow. They stand at the gates of the university. The administration slams the door in their faces. It was not because he lacked intelligence. He was brilliant. It was bureaucracy, pure and simple. Moscow University had strict regional restrictions. Because he was Siberian, he was technically supposed to go to the university in Kazan. Moscow just flat out would not take a student from the Tobolsk district. Imagine that, traveling thousands of kilometers, watching your mother deteriorate day by day, just to be told, sorry, you are from the wrong district. Go back. It must have been absolutely devastating. Most people would have turned back. They would have given up. But Maria Kornileva does not turn back. She says, fine. If Moscow will not have us, we are going to St. Petersburg. That is another several hundred kilometers north. So they get back in the cart. They keep going. They travel to the capital. And there, finally, she manages to get him enrolled in the Main Pedagogical Institute in 1850. It was his father's alma mater. A victory. She did it. She secured his future. But she had spent everything she had, all her money, all her health, every last drop of her energy. 10 weeks after Dmitry is enrolled in the institute, Maria dies. Just 10 weeks. And then, just a few months later, his sister Elizabeth dies too, likely of the same illness. So by the age of 16, Dmitry is completely alone in St. Petersburg. He is an orphan, but he has his mother's final words to him. She left him a letter, so she told him, refrain from illusions. Insist on work and not on words. Refrain from illusions. Insist on work. That became his operating system for life. You see it in how he approached science later on. He hated vague philosophy. He hated hand-waving. He wanted data. He wanted the work. He felt he owed it to her sacrifice. So he is alone in the capital. He is throwing himself into his studies. But the tragedy is not quite done with him yet. The ghost of his family's history comes back to haunt him. During his studies, he starts coughing. He starts spitting up blood. Tuberculosis. The same thing that killed his mother and his sister. The doctors in St. Petersburg examine him. They basically give him a death sentence. They tell him he will not survive the harsh, damp winter of St. Petersburg. His lungs are just too weak. So, just as he is finally getting started, it looks like it is all over. But he is just as stubborn as his mother. He somehow manages to graduate in 1855, top of his class, gold medal winner, even though he took many of his final exams from his bed. But he knows he can't stay. He has to leave. He needs a warm climate to breathe. He gets assigned to a teaching post way down south in Crimea. That means the Black Sea, sunshine, fresh air. Ideally, it would have been perfect. But look at the date. 1855. The Crimean War. He arrives in the city of Simferopol, hoping for a cure. And he finds himself in the middle of a war zone. The charge of the Light Brigade is happening just down the road. The school where he is supposed to teach has been closed. It has been turned into a military hospital full of sick and dying soldiers. The universe really was throwing everything it had at this guy. Here is poverty, here is blindness, here is a factory fire, here is rejection, here is a plague, and now, for good measure, here is a war. And yet, somehow, he survives. He eventually manages to move to Odessa, where the situation is a bit calmer. The climate works its magic. His lungs begin to heal. His energy comes back. And once he is healthy, his ambition comes roaring back with it. He knows he can't stay in Odessa. He knows that if he wants to be a world-class chemist, he needs to go to the center of the scientific world. And in the mid-19th century, the center of the scientific world is Germany, specifically Heidelberg. After earning his master's degree back in St. Petersburg, he manages to get a government fellowship to study abroad. He packs his bags for Germany. This is a huge deal. He is going to work with the titans of chemistry, people like Robert Bunsen and Gustav Kirchhoff. Bunsen, as in the Bunsen burner. But here is a little detail that shows you exactly what kind of person Mendeleev was. He gets to Bunsen's laboratory, the most famous, most advanced chemistry lab in the entire world, and he hates it. He thought it was messy. He complained about the noxious fumes, and he didn't like that he didn't have access to his own delicate precision equipment because he had to share. Mendeleev was particular. He was a perfectionist. So instead of just dealing with it, like everyone else, he takes his government stipend, rents an apartment, and sets up his own private laboratory in his living room. He buys all his own precision instruments. That is such a confident move. It is like saying, Professor Bunsen, your world-famous lab smells bad and your equipment isn't good enough. I am going to do my science in my kitchen. It is very independent, very Mendeleev, and it pays off. In that little apartment lab, he does some really significant work on capillarity and surface tension. In that cluttered apartment, he discovers something called absolute boiling point. Today we call it critical temperature. It is a really fundamental physical concept. It is the temperature above which a gas cannot be turned back into a liquid, no matter how much pressure you apply. You can squeeze it as hard as you want. It will stay a gas. Discovering a new law of physics in your living room is pretty impressive. But something else happens in Germany that turns out to be even more important than his apartment lab. The Karlsruhe Congress of 1860. This is the moment. This is the turning point. This is the event that plants the seed that will eventually grow into the periodic table. It was the first ever international chemistry conference. The who's who of European science was there, and Mendeleev is in the crowd, just listening. We need to drill down on this crisis of chemistry that was happening in 1860, because it sounds bizarre to modern ears. Why did they even need a conference? What was so wrong? It basically comes down to a fundamental confusion between atoms and molecules, and as a result, a total lack of standard weights for the elements. Let's take the simplest example. Water. H2O. We all learned that in school. 2 hydrogens, 1 oxygen. But in 1860, many chemists, maybe half the people in that room, thought the formula for water was just HO. 1 hydrogen, 1 oxygen. If you think water is HO, but it is actually H2O, all of your math is going to be completely wrong. Your entire foundation is flawed. If you think water is HO, and you weigh it, you might conclude that an oxygen atom is only 8 times heavier than a hydrogen atom. But if you know it is H2O, that there are 2 hydrogen atoms for every 1 oxygen, you do the math and realize oxygen is actually 16 times heavier. It is like having half the world using a ruler that is 8 inches long, and the other half using a ruler that is 16 inches long. And they are all trying to build the same building. The building is collapsing. That was the atmosphere at Karlsruhe. It was a room full of brilliant chemists all shouting at each other because they could not agree on the most fundamental numbers. You could not share research. You could not build on anyone else's work because everyone was using different definitions. Chemistry was stuck. So who fixes it? An Italian chemist named Stanislao Cannizzaro. He takes the podium on the last day of the conference. He gives this fiery, passionate speech. He dusts off an old forgotten theory by another Italian, Avogadro, and he proves, mathematically, that they need to standardize all the atomic weights based on gas volumes. He argues forcefully that oxygen is 16, carbon is 12, hydrogen is 1. He creates a standard. Mendeleev is in the audience for this speech. And while a lot of the older, more stubborn chemists in the room kind of rolled their eyes and grumbled, for Mendeleev, it was a revelation. He later wrote that the scales fell from his eyes. He realized that if the atomic weights are fixed constants, if oxygen is always 16, then that is the fundamental unchanging property of the element. That is the anchor he can build a system on. So he takes that core idea that atomic weight is the key, and he puts it in his pocket, and he carries it all the way back to Russia. And that brings us right back to where we started, to that freezing cold room in St. Petersburg in 1869. The textbook, the deadline. So now we understand the stakes. He has the correct weight data from Karlsruhe. He has the crushing pressure of the publisher's debt. And he has a stack of blank cards, the solitaire method. This is where the real genius happens. He starts creating a card for each of the 63 known elements. On each card, he writes the element's name. He writes its atomic weight, thanks to Cannizzaro. And he writes its key chemical properties, specifically its valency. That is essentially the Hooke number. It is how many other atoms an element can bond with. Lithium has a valency of 1. It can grab onto 1 chlorine atom. Oxygen has a valency of 2. It grabs 2 hydrogens. It is a simple measure of its chemical behavior. So he has 2 key variables for each element. Weight, how heavy it is, and valency, how it acts. And he just starts shuffling. He is looking for a pattern, a relationship, where the weight somehow predicts the behavior. He pins these cards to his study wall. He moves them around. He plays this game of chemical patience for days on end. He is exhausted. He is barely sleeping. And this brings us finally to the myth, the dream. The famous story goes that he finally fell asleep at his desk, completely exhausted, and the entire periodic table appeared to him, fully formed in a dream. He woke up, grabbed the nearest piece of paper, the back of an envelope, and wrote it all down. He even said, "I saw in a dream a table where all elements fell into place as required." It is a great story. It is very mystical, very romantic, the flash of divine inspiration. But historians mostly reject the magic interpretation of it. The dream likely happened, but it was not divine intervention. It was his subconscious finally processing the pattern that his conscious mind had been staring at for 72 hours straight. The work was the shuffling. The dream was just the final click of the gears. It was the culmination of years of thought and days of intense obsessive focus. So what was the pattern he found? What was the great insight? He realized that if you arrange the elements in order of increasing atomic weight, their properties repeat periodically. Hence the name. The best analogy is a piano keyboard. You start at a low note of C, then you go up the scale, D, E, F, G, A, B, and then you hit C again. It is a different note. It is a higher pitch. It is heavier. But it has the same harmonic quality as the first C. That is a perfect analogy. So lithium is like a loci. You climb the scale of elements, getting heavier and heavier, and then you hit sodium. And sodium is just a heavier lithium. They behave almost identically. They both explode in water. They have the same valency. They are the same note in a higher octave. Once Mendeleev saw that octave structure, he knew he had the map of the universe. He knew he had it. He quickly writes it all down. He titles his paper, "The Dependence Between the Properties of the Atomic Weights of the Elements." Not exactly a clickbait title. The presentation of this monumental discovery was even less exciting. He was actually ill. Or, some sources say, he was off visiting cheese factories because he was very involved in the agricultural cooperative movement, the biggest moment in the history of chemistry, and he might have called in sick to go look at cheese. It is possible. Either way, he did not even present the paper himself. His friend and colleague, Nikolai Menchutkin, stood up at the Russian Chemical Society meeting in March 1869 and just read the paper for him. The reaction was polite, underwhelmed even. Just polite. Why? Because other people had tried to make lists before. An Englishman named Newlands, a German named Meyer. They had seen some of these patterns too. So at first glance, Mendeleev's table just looked like another attempt to organize the elements. Maybe a little better, but nothing revolutionary. So why do we remember Mendeleev? Why is he the father of the periodic table and not those other guys? This is the absolute crux of the story. This is the move that takes him from being a good, competent scientist to a scientific prophet. The others, Newlands and Meyer, saw the pattern. But when the known elements did not quite fit, they tried to force them. They jammed them into the wrong slots, or they just gave up on the pattern. But Mendeleev did something radically different. He had the supreme intellectual confidence, the audacity, to say that the pattern is right. The universe is right. The list of elements that we have is incomplete. The gaps, the genius of the gaps. He looked at his card game. He saw that to make the chemical octaves line up perfectly, he had to leave blank spaces in his table. He said, in essence, there is an element missing here. We have not found it yet, but it must exist. That takes a special kind of courage. To tell the entire scientific community, my theory is not wrong. You all just have not looked hard enough yet. And he did more than just leave blank spaces. He named them. He used Sanskrit prefixes. Ika means one, so Ika aluminum was the element that should exist one step below aluminum in the table. Ika boron, Ika silicon. He did not just name them, he predicted their properties. He did not just say something exists. He said, when you find it, it will weigh this much. It will be this dense. It will melt at this temperature. He was literally prophesying the discovery of new matter. And this is why he is the Titan. Because he was right. And the way he was proven right is one of the greatest mic drop moments in the history of science. The gallium incident. Let us set the scene. It is 1875. 6 years have passed since the table was first published. A French chemist named Paul-Émile Lecoq de Bois-Baudran is working in his lab in Paris. He discovers a new metal in some zinc ore. He isolates it. He is very proud. He names it gallium, after France, which was called Gallia in Roman times. Lecoq is a serious guy. He is a meticulous, careful experimentalist. So he measures the properties of this new, shiny metal. He publishes his findings. He reports that the density of gallium is 4.7 grams per cubic centimeter. Science is done. The measurement is the measurement. Case closed. For anyone else in the world, yes. But Mendeleev reads this paper all the way over in St. Petersburg. He looks at his table. He looks at the empty slot he had labeled Ika aluminum. And he sees a problem. Based on the surrounding elements, aluminum above it, indium below it, the trend in his table required the density of this missing element to be roughly 5.9. So he has a choice. Either his beautiful table is broken, or the physical reality measured in a lab in France is wrong. He bets on the table. He writes a letter to Lecoq. You have to understand how incredibly presumptuous this is. He essentially writes, "Dear Sir, congratulations on your wonderful discovery. However, your measurement of the density is incorrect. My theory says it should be 5.9. I suggest you check the purity of your sample. Can you imagine getting that letter? Who is this bearded Russian guy telling me how to measure the metal that I am currently holding in my hand? Lecoq was reportedly quite annoyed, but to his credit, he was a good scientist. He was intrigued. So he went back to the lab. He repurified the sample. He removed the last traces of impurities, probably some sodium that was throwing off the weight-to-volume ratio. He then put the pure sample back on the scale. The new density was 5.91. That is just chilling. That is the moment where you realize this is not just a convenient chart. It is a fundamental law of nature. It sent a shockwave through the European scientific community because it meant the periodic table was not just a way to organize what we know. It was a machine for revealing what we don't know yet. Gosh, it was a map with "Here be dragons" written on it. Except the dragons were real. And then it just kept happening. The predictions kept coming true. Eka-boron was discovered in 1879 by a Swedish chemist. It was named scandium. Its properties matched Mendeleev's predictions perfectly. Then came the big one, Eka-silicon, which became germanium, discovered by a German chemist, Clemens Winkler, in 1886. Mendeleev had predicted, years earlier, that it would be a dark gray metal with a high melting point and a density of 5.5. Winkler discovers germanium. It is a grayish-white metal with a density of 5.35. It was an almost exact match. The scientific world had to concede. The system worked. It is amazing to think that he could see the invisible just by trusting the underlying logic of his system. But the system was challenged. What about the noble gases? That was the big crisis of the 1890s. A British scientist, William Ramsay, discovers argon and then helium. These gases are weird. They don't react with anything. They have no valency. They don't seem to fit anywhere in Mendeleev's columns. Did Mendeleev panic? Did he think the whole thing was broken? At first he was very skeptical. He actually thought argon might be a heavy form of nitrogen, N3 or something. He fought the idea of a new unreactive element. But once the evidence became irrefutable, he and Ramsay realized something brilliant. The table wasn't broken. It was just missing a whole wing, an entirely new column. Group 0, the inert gases. They added a new column on the far right side of the table, and suddenly everything fit perfectly again. The system was robust enough to absorb an entire new family of elements without collapsing. It actually made the table stronger. That is the sign of a truly great theory. It can adapt to new data. So we have established he is a chemical genius, a prophet even. But Mendeleev wasn't just a guy in a lab coat. He was everywhere, involved in everything. He was a true polymath and a fierce Russian patriot. For him, there was no distinction between pure science and applied science that could make Russia stronger. He was involved in cheesemaking, art criticism, national economics, and of course, heavy industry. Let's talk about the oil. He was huge on oil. Absolutely huge. He traveled to Pennsylvania to see the American oil fields. Then he went to Baku in Azerbaijan, which was part of the Russian Empire. He studied the extraction methods, the refining processes. He helped found the first modern oil refinery in Russia. And he had a very strong, very modern opinion on how oil should be used. There is that famous quote. He argued passionately against just burning crude oil for fuel. He said, and this is a fantastic line, this would be akin to firing up a kitchen stove with banknotes. Firing up a stove with banknotes. That is such a forward-thinking perspective for the 1880s. He saw oil as a complex chemical feedstock, not just something to burn for heat. He wanted to use it to make plastics, fertilizers, all sorts of petrochemicals. He understood that the chemical complexity locked inside those hydrocarbons was far too valuable to simply set on fire. He was about a century ahead of his time. And then there is the spy story, or let's call it industrial espionage, the smokeless powder. In the 1890s, the Russian Navy desperately needed a better gunpowder. The French and the British had developed this new smokeless powder, which was a massive military advantage. If you shoot and there is no big puff of smoke, the enemy can't see where you are. You are invisible. But the formula was a top state secret. So the Tsar asks Mendeleev to figure it out. Does he sneak into a French lab in disguise? Nothing so dramatic, but perhaps even more clever. He uses open source intelligence. He travels to France and England on a government commission. He can't get the formula, obviously, but he asks to see the public railway records. The train records. Why? He looks up the records of all the chemical shipments going into the secret gunpowder factories. He sees how much nitrocellulose is being delivered, how much sulfuric acid, how much alcohol. He does the stoichiometry, the chemical math, to balance the equation. And from that, he deduces the recipe. That is absolutely brilliant. It is like Sherlock Holmes with a chemistry degree. He invents his own version, which he calls pyrocolloidine, and by all accounts, it was actually chemically superior to the foreign stuff, more stable. So did the Russian Navy adopt it and win a bunch of battles? Tragically, no. Bureaucracy and military infighting killed the project. The Russian military establishment was notoriously slow and corrupt. They ended up not producing it, and I believe they later bought a worse formula from the Americans. But Mendeleev had done his job for the Tsar. We also have to talk about the balloon flight, because every time I picture this scene, I smile. No, it is one of the great stories. It is 1887. There is a total solar eclipse visible over Russia. Mendeleev wants to study the sun's corona from above the cloud layer. He is 53 years old. He is heavy. He has that giant beard. And he has never flown in his life. But he arranges for a hydrogen balloon ascent from a field near Moscow. The weather is terrible on the day of the eclipse. It is awful, rainy, gloomy. The balloon is soaked with water. The physicist who was supposed to accompany him gets into the basket. Mendeleev climbs in, and nothing happens. The balloon is too heavy with all the rainwater. It won't lift 2 men off the ground. So the sensible thing to do is scrub the mission and go home. That is what any normal person would do. But Mendeleev does not do sensible. He looks at the professional pilot and says, "Get out." He kicks the pilot out, the one person who knows how to fly the balloon. He climbs into the basket alone. He has zero experience. He manages to untangle the wet ropes. He throws out the ballast, and he just shoots up into the sky by himself. He disappears into the clouds. His family and wife are on the ground, terrified. He breaks through the cloud layer into the sunshine. He sees the total eclipse and makes his scientific observations. It is a complete triumph. But then the valve line that lets the hydrogen out gets tangled. The balloon won't come down properly. So he has to climb out onto the rim of the basket, thousands of feet in the air, to untangle the rope so he can land. That is straight out of an action movie. He lands safely in a field miles away. The local peasants are amazed. They think he is some kind of god descending from the sky. He becomes a national hero overnight. He gets a medal for bravery from the Aeronautical Society. It just shows his sheer dedication. He would literally risk his life for a single data point. We have talked about the hero, the genius, the spy, the balloonist. Now we have to talk about the man and the scandal, because his personal life was complicated. Very complicated. And again, it really comes back to his stubborn, all-or-nothing personality. His first marriage to a woman named Feozeeva was a complete disaster. It was essentially arranged by his well-meaning sister when they were young. They were totally mismatched. Mendeleev was intense, brilliant, and work-obsessed. She was quiet and domestic. They lived apart for a long time. And then, when he is 43 years old, he meets Anna Popova. She was 19, an art student. She had come to his house to take drawing lessons from a friend. It is quite an age gap. The cliché of the professor and the student. He fell obsessively, head over heels in love. This was not a casual affair. He was completely consumed by it. When Anna's parents found out, they were horrified. They sent her away to Italy to get her away from this older married man. But Mendeleev was not deterred. Not in the slightest. He followed her. He pursued her across Europe. He eventually told her that if she did not agree to marry him, he would throw himself into the ocean. It was extremely traumatic. So he goes back to Russia, and he divorces Feozieva. But here's the catch. In 19th century Russia, the Orthodox Church was the law of the land when it came to marriage and divorce. And the church was very strict. After a divorce, you were forbidden to remarry for 7 years. It was a kind of penance period, 7 years. Mendeleev did not want to wait 7 years. He definitely did not. In 1882, just the year after his divorce was finalized, he finds a priest in a village church who is willing to overlook the rules for a fee, a substantial bribe, 10,000 rubles supposedly, which was an absolute fortune at the time. The priest marries them, but technically, legally and religiously, Dmitry Mendeleev is now a bigamist. He has not served his 7-year penance. This caused a huge uproar. The most famous scientist in Russia is openly breaking church law. The scandal was the talk of St. Petersburg society. His enemies were delighted. People complained to the Tsar. There is a wonderful story about a Russian general who also wanted to remarry early. The church told him no. He complained to the Tsar, asking why Mendeleev is allowed to have 2 wives, and the Tsar's response is the favorite line in this whole story. Tsar Alexander III is reported to have replied, "Mendeleev has 2 wives, yes, but I have only one Mendeleev." That is the ultimate get-out-of-jail-free card. It shows you his status in the Russian Empire. He was untouchable because he was seen as indispensable to the state. He was the brain of Russia, but it did cost him socially and professionally. The Russian Academy of Sciences in St. Petersburg, the most prestigious scientific body, was very conservative. They never admitted him as a full member. Part of it was his prickly personality. He was known for shouting and having a terrible temper. But the bigamy scandal gave his enemies the perfect excuse they needed to keep him out. Speaking of enemies and snubs, we have to address the Nobel Prize, or the lack of one. Mendeleev died in 1907. The Nobel Prize was started in 1901. He never won. It is widely considered one of the biggest, if not the biggest, snub in the history of the prize. He was nominated in 1905, 1906, and again for 1907. He should have won. It was a foregone conclusion for many, but he had a nemesis, a Swedish chemist named Svante Arrhenius. The politics of science are brutal. Arrhenius was a giant in chemistry. He won the Nobel himself in 1903, but he was also a very powerful and influential figure on the Nobel Committee. And years earlier, Mendeleev had brutally criticized Arrhenius's theory of ionic dissociation. Mendeleev just did not think the theory held water, and he said so very publicly and very harshly. Arrhenius held a grudge, a deep one. When Mendeleev's name came up for the 1906 prize, the chemistry committee actually voted to give it to him. But Arrhenius intervened at the last minute. He argued that the periodic table was too old of a discovery. He claimed it was ancient history, not a recent discovery, as the will of Alfred Nobel stipulated. He managed to sway the full academy to give the prize to Henri Moissan instead for isolating fluorine. So purely out of spite, he blocked it. And Mendeleev died of influenza just a few months later, in early 1907. Nobels are not awarded posthumously, so he missed it by a hair's breadth. That is tragic. But when you have an element named after you, that is a better prize than a medal from Stockholm. Element 101, Mendeleevium. It was discovered in 1955 by American scientists at Berkeley. In a wonderful gesture, they named it in his honor. So he has a permanent spot on his own table, and there is a massive crater on the far side of the moon named after him. Not a bad legacy for a kid from Siberia who had to hitchhike to college. So as we wrap up this incredible story, let us try to synthesize this. What is the real lasting legacy here? It feels like it is so much more than just a chart on a wall. It goes back to that idea we started with, order from chaos. Mendeleev did not just find a convenient pattern. He gave us a map of nature's fundamental laws. The periodic table is the alphabet of the universe. You could travel to any alien civilization anywhere in the galaxy, and if they do science, they will have a periodic table. It might be shaped like a spiral or a pyramid, but the underlying order proton by proton, shell by shell, will be exactly the same. It is an objective truth. And it came from a man who was messy and emotional. A man who worked too hard and loved too hard, and who absolutely refused to accept that things were impossible. He showed us that the universe makes sense, even if our own lives often do not. The universe makes sense even if we are messy. And that map he drew is still guiding us. Every time scientists create a new, super heavy element in a particle accelerator, they are just filling in another box. They are occupying a space that his law created more than 150 years ago. You will never look at that chart on the classroom wall the same way again. It is not just a bunch of boxes. It is a story of survival, of obsession, of incredible insight. It is a human story. If you enjoyed unraveling the life of this scientific titan, and you want more stories about the people who built our modern world, make sure you are subscribed to the History Titans channel. Hit that subscribe button. We have some incredible investigations coming up on figures you think you know. Trust us, you probably do not know the whole story. Like this video, if you enjoyed it. Share it with a friend who loves a good genius with a scandal story. And please leave a comment. We really want to hear from you. Which of the History Titans should we cover next? Thanks for listening, everyone. Keep asking questions. Keep looking for the patterns.